This session I'm going to introduce hanging lighting equipment, and in order to do that I'm going to set up a temporary stand, and that'll give me an opportunity to show you several pieces of theatrical equipment and explain how they're used. Most theater equipment is designed to be hung from pipes, which typically are in an overhead grid, or in many theaters in a system that allows them to descend down to the floor and then go back up to a typical height where they'll do their job well. That's called the trim height, and that's fairly common. However, it's very, very common that we work with temporary structures made out of, quite frankly, black plumbing pipe. And that's what this is. This is a piece of plumbing pipe that is actually threaded, meaning it has threads cut into it so that it can be inserted and screwed into a base. And then that allows us to make temporary structures, most commonly around here, used on the sides of the stage. And if we set something up, a vertical lighting position like that, it's named a boom. And so this is a pipe, not particularly this one here. This is a shorter than normal one. But on the floor here, we've got a whole set of different pipes. We've got one of our old style bases that you see over here. You see the cart that carries them, and these are the flat square plates that are boom plates, and then the tools that we use to deal with all of this. So first things you need to understand is that we're working with plumbing pipe. And so even though it's not being used for plumbing, it's important to understand a few basic things about it. It is plumbing pipe, and so what plumbers obviously care about is how much can be carried in the pipe. And for a plumber, that means that the interior diameter of the pipe is crucially important. And there's two standard sizes rather that have been used in theater traditionally, and they're named the way plumbers would name them. So it's in imperial measurements, this being North America, or at least this being North America as in the part of North America that deals with construction, meaning the part of North America that sells most everything to the United States, and so therefore is typically dealt with in imperial measurements, inches and fractional inches and feet. This smaller size here is a common older size, especially up on the hill at SFU, and it is known by its outside diameter. Actually, that's wrong. It's known by its inside diameter, and that this is commonly called 1.25 inches, as opposed to this larger size, which is called 1.5 inches. Now, because those are the inside diameters, it actually is not the size of the pipe. So as far as we're concerned, this pipe is 1.25 inches. It's called Schedule 40 because it has a certain thickness of wall, if it interests you, about 1/8 inch. And this is called 1.5 inches. Really, 1.5 inches on the outside is just a shade under 2 inches. And 1.25 inches Schedule 40 is, if I remember correctly, 1 5/8 or something like that. We only use these two sizes, and it's important to understand that because much of our equipment is is based around the larger size, and the older equipment that we've brought down with us is the smaller size. This is one of the older bases from up on the hill, Burnaby campus, and they were sized for the smaller pipe size, 1¼ inch, schedule 40. So we've used these in Studio D&T, and we have a selection of different sizes because some of these are used with instruments quite high up. And so you need to know how to work with that. One thing to know is that there's a pretty straightforward way to get it vertical, which is by walking it up, which I just did, and it may have been off camera. And the other thing is you have to know how to thread this pipe in without damaging the threads, because if you cross-thread it and tighten it, you can make it impossible to use again. So the trick is to know where the thread starts, and that's easily done by winding it backwards. And backwards is counterclockwise, but let's talk about that in a second. But if I wind it backwards, you'll hear it drop down if I'm really quiet. I'm not sure you heard that, but it's quite probable that you did. So now I know that the threads are just ready to engage, and so I wind it on by hand, keeping it straight until it's fairly tight, but not excessively tight. All right, now we're going to have to talk about tightening and loosening. And that's all right, so now we're going to have to talk about tightening and loosening as it relates to threads. And that's putting us into the subject of nuts, bolts, screws, you name it. If you ask many people how they remember which way tightens something and which way loosens it, they'll say something like righty-tighty, lefty-loosey. You have to ask yourself, what do they mean by that? Well, it's problematic doing it on camera, but essentially, if I'm talking about righty-tighty, I have to be referring to, I'm looking from the head of the bolt, or the unthreaded part of the pipe, towards the threads, and I have to be thinking about going from left to right as I look at it in that orientation. So what I'm really saying is a normal thread tightens clockwise and loosens counterclockwise if I am facing the way I just described. However, if you think about it, righty doesn't apply on the bottom. It doesn't apply when the bolt is turned the other way. It doesn't apply when the bolt is right side up or upside down, depending upon where you're looking at it from. So what you have to realize is most things go from being finger tight to tight enough in a very short amount of turning. Typically, in the kind of things we're going to be doing for hanging lighting equipment, 1/8 to 1/4 of a turn. So something properly tightened in this world, if you're tightening it and it hasn't gone from finger tight to tight, but has done something different, like loosen, you have to stop and think. If you think it's tight already and you're loosening it and it's not going anywhere, ditto. You have to think again, and you have to be able to flip your point of view mentally, and so on. So in terms of the pipe, because it has a much larger surface area and the actual threads are fairly large and they get abruptly cut off, it's reasonably easy to cross-thread it and start it in wrong. And that can lead to damaging the stand. So we've got this stand assembled and finger tightened, but it's important that it be tighter than that, or else, depending on which way things are set up, it can be quite easy for the lighting instrument to shift just by having enough rotary force from its weight to loosen the pipe. Okay, so we need a way of tightening this, and that's what these pieces of equipment here are for. These are wrenches. For those of you who have never seen this word written, like many strange English words, it's spelled W-R-E-N-C-H. And these are, of course, adjustable pipe wrenches. Here's a pipe wrench close-up. And here's a smaller one. Now, this is not a bad place to introduce another concept. Any kind of a wrench, whether it's a pipe wrench or a non-adjustable wrench or whatever, allows you to get very significant force because it either fits over something like a bolt head or it grabs something like a piece of pipe. And if you use it properly, you're using leverage to increase the amount of force you can put on something. I know it seems like a basic concept, but I can't tell you how many times I get to see people saying, oh, I can't actually tighten this, and then I see them holding the wrench like this instead of holding it like this and getting an increased length, an increased size of lever, and therefore able to apply more force. So wrenches are, for example, here, this is a 14-inch pipe wrench. This is an 18-inch pipe wrench. It's obviously designed to increase the amount of leverage. A pipe wrench is a bit of a curious piece of equipment. It's actually quite loose when you set it up. And it has actually got measurements here, but that's not really as important as you might think, because the way a pipe wrench works is you put it on to the pipe relatively loosely, and when you go to turn the pipe in the correct direction, it actually grabs the pipe and turns it. But it won't do the reverse because it's quite loose that way. So if I wanted to take the pipe the other direction, I have to change the wrench, and that may, depending on where I am, mean a little more adjustment so that I can get it tight enough to grip it. All right, so that's actually the pipe wrench working properly. So for the purposes of this demonstration, I've set up a second stand, and now what I want to do is put a horizontal piece of pipe across these two. And there's a different kind of attachment system for doing that. So now if I want to tighten this pipe into the stand, I have to think about tightening it. from the point of view of righty-tighty, lefty-loosey, or more accurately, counterclockwise for loosening, clockwise for tightening. So if I look from the bare pipe towards the threads, then it's going to be rotating in this direction to be clockwise. So if I put the wrench on the pipe, which is a smaller piece of pipe, in such a way that it fits in a bit, and I grab it like this, I can tighten the pipe. Now, I want you to notice that I went from being finger tightened to almost too tight to easily get it off in about 1/8 of a turn. So just to repeat that, here's how far I can tighten it by hand as long as I've kept it vertical. And then a wrench literally has to move that far, and I can't budge that with my hands. It's a very common requirement to add pipes to the system. It may be because we're using booms, like the vertical positions, and we want to put cross pieces on them at specific heights. It may be that we need a pipe overhead and there isn't one already installed in the grid at that location or on that exact angle or whatever. So we have a couple of systems that we commonly use. This is called a key clamp. This particular one is actually a key clamp. It's a British piece of equipment, and I don't know if you can see. Yeah, you can actually see KEEKLAMP. It uses a very particular kind of screw. This is called an Allen screw, ALLEN. And the reason it's called an Allen screw is because an Allen wrench, which is a hexagonal cross-section wrench, is designed to fit in this socket and allow you to tighten or loosen the set screw. I'm sure many of you have seen these in IKEAs or IKEA furniture. We commonly use an Allen key that has a T handle on it, and that's because many of our systems, the seating systems, these key clamps, quite a few different things use Allen set screws. Okay, now because we have old size pipes, 1.25" schedule 40, and new size pipes, 1.5" schedule 40, we have two different sizes of Allen key clamps. So here's an 1.25" one, and you can see this is a smaller pipe for us, 1.25". This one fits on it. The other size, 1.25", will never tighten, and the small size socket-driven key clamp will never fit on the larger pipe. So that's one thing. You have to know what size you're working with. And we have, primarily for lighting purposes, we have cross pieces that are set up for specific sizes of pipe. So imagine that this was the base, the boom, the vertical component, and we were putting a cross piece on it. that cross piece would be set up like this. And then in order to set the height and set everything else, you simply insert the Allen key, and you can use it quite a few different ways. There it is, tightened into the pipe going horizontally, and here it is set up for the vertical. And once I tighten those, it's comparatively secure, and it will stay at the height that I set it to, all things being. If we're setting up a prefabricated system like the lighting booms for the side of the stage, then the key clamps are a very quick and easy way to go. But if we're setting up something such as this lighting stand I'm about to put together for this demonstration, or perhaps we're adding a pipe to the grid, the key clamps don't always work very well. Either you can't get them on because there's no way to put it over the pipe because it's welded together, or they're just not strong enough for the job. So another common piece of equipment around here is this clamp. These are called cheeseborough clamps. That's like cheese with burrow on the end, if burrow is spelled B-O-R-O-U-G-H. Great English spelling. And what they allow us to do is clamp pipes crossways, side by side, lots of different things. So the way a cheeseborough clamp works, and yes, technicians have long ago called them cheeseburgers, and not only that, but some very slick, fancy aluminum ones are actually brand named Pro Burgers. So if somebody asks you for a cheeseburger, they're not necessarily hungry. They are probably wanting you to get one of these. And the way these work is you loosen it to the point where you can easily pivot it on and off the pipe. You make sure that the washer, this ring here, ends up being outside of this part of the clamp, and then you swivel it on and you tighten this, and then you do the same thing for the pipe in the other orientation, and so what you end up with is an arrangement like this. Which you can tighten quite incredibly, and we'll talk about that in a second. But first, I have to introduce another tool. This is another kind of wrench, and in fact, it's one of a family of wrenches that are adjustable. So we can change the size of the opening on this wrench so that it can work with a wide variety of nuts, bolts, anything that you can actually tighten, that you can get a grip on with something like this. There's a family of wrenches like this. This one happens to have been popularized in North America by a company called Crescent. And so most people refer to this as a crescent wrench, or trendy people refer to this as a C wrench. It is an adjustable wrench. They're not incredibly expensive. In fact, even now the Crescent, which is a reasonably high quality wrench, is quite affordable. There are some important things about this, though. First of all, this is here an 8-inch crescent wrench. or in metric terms, it's a 200 millimeter wrench. It's a 200 millimeter wrench if you hold it at the end of the handle. If you choke up on it and hold it like this, it's a 2-inch wrench. So that's a good thing to remember when you're back in the facility and you can actually talk to a human being in the same room as you, because I can't tell you how many times I've had people learning tell me, this is too tight, I can't get it loosened, and then I look up and I see them holding the wrench like this. If you hold the wrench out at the end of the handle, logically speaking, you have a lot more leverage. These come in many different sizes, common sizes, 6-inch crescent wrench, 8, 10, and so on. They go up to being quite sizable. 8 inches is kind of the industry standard, although I did have a friend who was the lead technician at a national theater where the techs were bodybuilders, and he finally took away their 8-inch crescent wrenches and gave them 6-inch crescent wrenches, so any normal person could still loosen something they'd tightened. Other things about this, we've always got ours outfitted with something, either something as simple as a wrist strap like this, or especially if you're working overhead, this is a safety lanyard that's on the crescent wrench, and that's so that you can clip it to something on your body, and it won't fall if you let go of it. Similar arrangement here with a wrist strap. The thing to remember, which we'll get into a little bit more later, is if you drop even an 8-inch crescent wrench from 20 feet and it hits somebody, there's potential for very serious injury. So you need to keep that in mind. The crescent wrench opens and closes by running a thumb screw here that opens it up or closes it down, and people become habitual about knowing this, what this feels like, to the point where somewhere around here there was a crescent wrench that had somehow been reversed, and in frustration, after I picked it up one too many times, it went to metal recycling. It just drove me nuts. Okay, so back to the Cheeseborough clamp. How does this work? Well, first of all, this one's a swiveling Cheeseborough clamp, and so it can actually pull together two things at different angles. There are some things to know about it. For starters, this T-shaped piece here, for it to work when it's being tightened, it has to be firmly into the socket, if you like, that holds it. And second of all, whenever it's closed, it has a nut on it and a washer, and the washer has to be outside this part that swivels in and goes on to the bolt. So the washer is always between the nut, the hexagonal head nut, the washer, and then the casting of the Cheeseborough itself. Second of all, these nuts are deliberately made so they cannot come off. They have a punched out thread at the end here, and so please do not put a wrench on these things and ruin them by forcing them to come off. You never need to take that nut any further than the opening here. If you have a situation where this Cheeseborough clamp won't fit over something you're trying to clamp it to, then you've got the wrong clamp, not something that you should force open and close, because you'll simply ruin it. Okay, so the nice thing about a Cheeseborough clamp is that you can use it to clamp a smaller pipe to a larger pipe simply by fact that they can adjust. So there's an 1.5-inch pipe ready to tighten the clamp. Here's 1.25 inches. I've got to pull this washer up here, and then I can finger tighten that. And it's the same as I explained before. If I've got this relatively tight like that, I can make it extreme. So there it is gripping, and now there it is firmly locked. So not that much between I can move it and now I can't move it at all. Lastly, let me tell you about adjustable wrenches and nuts and bolts, hexagonal heads, or for that matter, square heads. But in particular with hex head bolts and nuts, it's important that you have the adjustment tight enough that you can't force it to go over the point of the hexagon here. Because what you'll do is you'll round it over. What you learn when you're working with these is how tight it has to be so that you can really reef on it, but still get it off and on. And in truth, people habitually are doing minor adjustments that you might not see until you look really carefully with their thumb. But crucially, don't use a wrench that is not tight at all and force it over the point, because what you're doing is effectively weakening the connection between the wrench and the nut to the point where eventually we'll have to replace something. So we're going to do this by supporting a pipe, a cross pipe. This one here, which is comparatively heavy, across two of these stands. And we're going to do it using 2 cheese burros. It's always a good idea to think before you do this. And the question you want to ask yourself is, which of these 2 components should I put the clamp on first? And the answer, regardless of the situation that you're in, whether you're hanging a horizontal pipe on a vertical stand, or you're underhanging a pipe underneath the lighting grid, or on top of the lighting grid, the question that you want an answer to is, what will be the easiest in the long run? So people will often think, oh, okay, so I've got the length all set up here, so I'll put the clamp on the pipe that's going across. A moment's thought will tell you that then you're going to have to hold the pipe and all of its weight while you desperately try to connect to a vertical pipe and get it to stay there. So in this case, the obvious answer is no. We'll put the we'll put the cheese burro on the vertical first. And I'm just setting this up so that it's going to be at a nice, comfortable height for us to demonstrate hanging a lighting instrument. And we're going to be able to do that without any strain introduced by being up in the air on a lift or anything like that. So really all I need is the opening of this cheese burro more or less at a right angle to where the pipe is going to go, and to have them, in this case, almost at the same height. For this setup, it's really not that important if these are really beautifully matched in height, but in a production, it's worth going to some effort, because it's just going to give the impression that things are more professional, that the people cared about how things looked. So we try to make our setups neat so that if somebody is looking at the setup instead of the performance, they'll have something nice to look at. All right. The next thing is to think about how to prepare these. Some questions that are relevant are, is this set up so that I have the cheese burrow positioned so that I can support the pipe in it without doing a lot of holding? This is not going to work very well, but this is going to work quite well. Second of all, have I got it backed off, the nuts that is, backed off to where I can easily swing the cheese burrow up and have it close? And then the answer is yes. And now you'll see why I said it was important to think, because that was the maximum effort I had to do right there to lift the pipe up into the support of the cheese burrows. And now I can simply lift it up and hook them. Usually I'd be working with somebody. In this case, I guess I could have backed it off a little more even. So, oh, nope, I didn't have it adjusted. Nope, even so, I could have backed it off some more. And I had the misfortune to pick a cheese burrow that some careless person has jammed the threads. So I cannot, in fact, easily hook it on. Now that happens because a careless person has closed their wrench on the threads instead of the nut, or they've let the wrench flatten the threads while they were tightening it. Something to think about. All right, how tight does this need to be? Well, the question about tightness is one that is something that you have to learn, because I can't actually tell you what it feels like to you when something is tight. I can tell you that, or I can at least remind you that it goes from being more or less snug like this to really tight and not that much of a turn, certainly less than a full turn even with a cheese burrow like this. But what we are doing here when we set up lighting positions is we are ensuring that this pipe can't rotate. It's firm and it's grabbed tightly enough that it can't rotate. And in this case, the cheese burrow gripping the boom is quite tight, because that way, no matter how many instruments we hang on this position in this limited amount of space, it's not going to tend to slide down. When we get to talking about focusing, I will tell you more about that. Another essential piece of equipment that we need to talk about is the C-clamp. Now, okay, it does look like a C, but then so does a different kind of clamp that's used for clamping pieces of wood together, also called a C-clamp. This is the kind that is specifically to be found on almost any kind of lighting instrument or component that's ever going to get hung from a lighting position. And generally speaking, there's agreement about these with a single exception. The C-clamp is designed, and let me get a piece of pipe. The C-clamp is designed to hang from a pipe. So in order for that to work well, several conditions have to be met. First of all, the pipe has to be inserted, or in this case, or realistically, the instrument lifted up and shifted on to the pipe and pushed in so that the pipe actually is contacting both sides of the C-clamp. It's possible to tighten it like this with the pipe actually gripped by the nut, sort of, but that's a recipe for problems because it may not fall out. In fact, if you're using proper procedure, it won't matter if it falls out, but it's not going to be well gripped. So first things first, the pipe has to be in the corner of the C-clamp, right up so that you can see no air between either sides. All right. This square-headed bolt here is designed to drive in and grip the pipe. It can be tightened too much, in fact, but it has to be tightened adequately, but not so tight that you need to use an excessive amount of force to take it loose again. Every C-clamp also has a hexagonal bolt coming up into a post here, and that is for tightening the C-clamp onto what's called the yoke of the instrument. We'll see that in a minute, but it's essentially a yoke, Y-O-K-E. It's the same as for a carriage, you have a yoke that goes around the horse. And in this case, the yoke has a central hole in it, and that is gripped by this post here. We'll talk about this again as well. And then most clamps have a smaller square-headed bolt here, really not a bolt as much as what's called a set screw, and that's to grip the post and be able to lock on like this. Almost every time the post should be down, seated in the casting of the clamp and tightened here. There are rare occasions where you might have to lift that up for some reason having to do with clearance, but generally speaking not. Okay. This part of the clamp, the main body of the clamp, is cast iron, and that's one of the reasons for the procedure that I'm about to lay out in detail. Here's the way the instruments are going to come off the storage racks. Set to hang straight up and down, and with the adjustment on the C-clamp a little bit too tight to go over the pipe. What are you going to do to hang it? I'm going to work in what would be an inconvenient position for me to be in, but so that you can see what the procedure actually is. First things though, it's courteous and efficient to set all of the lighting instruments on a pipe the same way, at least with the C-clamp open in the same direction. If you have a theater that has permanent lighting positions and they're always oriented towards a stage, then you can make a rule like always hang the instrument with the C-clamp pointing away from the stage, in the sense of pointing as in the tightening bolt and the opening are away from the stage. And that would typically be because you're always working from that side, and so you have easy access to the bolts and so on. In here, in one of our studios, it's essentially the case that if you come along and somebody has started to hang them in one position on a given pipe, then you match that. And it's for a simple reason. You're up there on a lift or in a theater that has the fly system. You're down on the floor and the pipes have been lowered in with the instruments all over them. And the last thing you want to do is drive your lift back and forth from one side of the pipe to the other to do anything, like, for example, to take them all down, what we call the strike, or have to duck underneath heavily laden pipe to work, or work inconveniently with your wrench on the far side, like I'm going to do today. So that's a general rule, is just match what's there, because the clamps can be one way and the instruments can be adjusted to a different position. There's a procedure that is critically important, and that is always used when hanging. The only time it's not crucial is if you are hanging on a vertical position a foot off the ground, but we're not going to change it just because sometimes you can avoid doing it. All right. Procedure is essentially make sure everything that you're going to need to work with right away is clear and out of your way. So in that case, that simply means the cable is adjusted so that it's hanging free, so you don't have to futz with it later on. And you have a sense from looking at the lighting plot of how this instrument is going to end up being pointed, because it could easily be one instrument is pointed on an angle like that, the next one is pointed facing the upstage wall, the next one is pointed straight down. So it's good to know that, because these instruments all have a top and a bottom, and for some of them, hanging in the right orientation is quite important. For others, not so much so, but it's just courteous and a good habit to develop. Okay, so if I know that this instrument is going to end up being tilted that way, then I need to know that it's going to end up right side up when I adjust it. Maybe you could think about what that might mean while we go on with this procedure, and we'll come back to it when we actually look at lighting instruments and talk about hanging them. Okay, so I said I'd do this backwards, so I'm going to have to train myself to do it. The first thing to do is lift this instrument up and move the C-clamp onto the pipe so that the pipe is snug in the upper corner of the C-clamp like this. The second thing is leave your hand holding it safe on the pipe while you run in the square bolt until it just hits. And then you might think, okay, get your wrench out and tighten that. And of course, now that I've asked it that way, you are probably going to suspect that that is not what I want you to do. In fact, that's not what anybody wants you to do. What everybody wants you to do is take the safety chain or cable or whatever, loop it around the pipe and clip it to itself, or if it's a different configuration, attach the safety to, listen to me, something that is attached to the building. I know that sounds crazy, but I can't tell you how many times I've seen this. And this is not going to do any good at all. You have to attach it to something that is actually attached to the building. Why? Why is that the second thing? Well, on a rare occasion, one of these cast iron clamps will snap, and I mean rare, like a handful of times in 4 decades. If that happens, or if somehow or other you have not followed proper procedure and you can knock the lighting instrument off, it's going to fall that far. It's not going to fall the 21 or 22 feet to the floor. So, C-clamp on, held in place, finger tightened. Safety on, and now take the wrench onto the square bolt and tighten it. How tight is tight? Well, again, this depends a bit. Definitely, if I go, here's a point of reference, that's finger tight, and I can move this instrument like this. I tighten this that much in my case, and I can't shift this at all. It's relatively easy to tighten it so tight that it's difficult to get it off, and it's relatively easy to tighten it so that it can move on its own. It seems a bit counterintuitive that it would move on its own, but that's simply because, like the vast majority of lighting instruments, it's tightened hanging straight down. But it's not at all uncommon to have the lighting instrument side hung like this. For some reason, like you need clearance or something like that. And then you can imagine that it would be relatively easier, much easier for the lighting instrument to work its way down, especially if there's any kind of vibration or anything like that. Please also notice that I was very careful when I hung this to hang the instrument so that the rotation that could result is going to tend to force the square-headed bolt into the pipe, rather than if I had hung it with the thing the other way, which, for example, would have been comparatively easy. Suppose the requirement was that I hang the instrument the other way. Like this, then I would be inclined to reverse that clamp, because then the weight of the instrument rotating down would tend to make it go looser, not tighter. So there are circumstances where rotation is possible and the tension of the nut is important. So there are circumstances where the position of the C-clamp has to be reversed, and where the amount of force put on the square bolt might have to be a little bit more to make sure it stays where you want it to stay. I said also that the instrument wants to be right side up. So maybe I should talk briefly about that. And I'll deliberately tilt it towards you upside down, although these are well-made instruments and this wouldn't be so much of a factor. But look, there's always a place in the front of a lighting instrument where you can insert a filter or other accessories. In this case, it's got a clip, so it's not going to fall out. But assuming the instrument hasn't been assembled incorrectly, that is the top. And so I would, in this situation, with most instruments, deliberately rehang that. So the way it was set up is really set up to go pointing upstage like this. And it's also the case that will usually result in the power cord coming out of the bottom, quote unquote. Now, not so relevant if it's pointing straight down, but that's the way to properly hang a lighting instrument, is right side up. While I'm talking about that, I've been actually demonstrating the way that you make one of the adjustments in a lighting instrument, and that's by pivoting it on the yoke. This is the yoke. So this means of pivoting on the support, on the yoke, which always has some kind of a handle that allows you to tighten it and loosen it. And again, that's too loose. That's going to adjust itself. That's nice and snug. It's not going to adjust itself. But that is tilt. That's tilt, right? So the other adjustment is pan. And here's where we come into a disagreement. Some people have been taught to use the large bolt that holds the post onto the yoke and pan the instrument, panning from left to right, right to left, and then tightening it by tightening this bolt. Other people, equally good technicians, have been taught to loosen the little set screw and rotate the whole post, and it's largely a matter of training. I have a preference, which you can figure out if you watch me work, and the other factor is some very good clamps don't have the set screw at all. However, this is one of the places in the procedure where we agree to disagree. We don't disagree about the order of finger tightening and then safety cable, and we don't disagree about the tightness of the square bolt. Let me just say about this, if you go to tighten the pan with whatever method you use and it hasn't tightened, then you need to know that the other possible tightening and loosening option exists, so that you can check and see if it's loose and tighten it, and then go back to using whichever one you're most comfortable with. Here's another wrinkle in hanging instruments or various other things. This is called a downpipe, and it's a way of hanging an instrument, either clamping it sideways onto here. Sometimes downpipes have a way of going straight onto a yoke. We didn't do that. But it's simply got a C-clamp attached to a pipe, so I can put it here and tighten it on instead of an instrument, and that allows me to drop that instrument down for some reason or extend it sideways or whatever. So I can actually make a lower hanging position off of this horizontal pipe, but that's a downpipe. If you're working with a relatively experienced designer, they know from the program they're using and their experience, how much space a given lighting instrument takes up, and they make automatic adjustments according to where the instrument is going to end up being pointed. But it's good to know that if you think this instrument, for example, is going to block the light coming out of the one that I'm going to hang next to it for some reason, then you can question that. That makes perfectly good sense to question it. But in any case, you need to build up your experience to where you know that whatever you're doing when you hang the instrument, is going to allow you to move it. So that brings me to, what do you do with the cable? What we always do with the cable is leaving enough length to be able to point this in whatever direction it would need to be pointed in, which usually means bringing the connector right up on top here, and then appropriately tying this with cable ties when you plug it in, or if you're plugging right into a circuit box, it should have enough room, so no point in stretching this over here, because that leaves you absolutely no room to maneuver the instrument. It does if you're pointing that way, but the minute you have to make any other kind of adjustment, this is too tight. So it seems curious at your level of experience probably, but you should connect it here and put in a 1 meter cable to a box that you think you could reach, just because that way you know that later on when you're working in the dark, or somebody else is, and we're in a situation where we're hanging and focusing, we're not going to have to stop and fix something. Let's talk plugs and circuits. This wall circuit here is for a 15 amp 125 volt alternating current. It happens to be orange because it has been very carefully wired for sound and operating systems so that there is no current flowing in the ground wire. That's where you get the strange humming noise that you'll sometimes get, not feedback, but you'll get a humming noise in certain audio systems, which is merely an amplification of the 60 cycle tone that results from North American alternating current. Now, interestingly enough, it's a different tone, a deeper tone, 50 cycles in much of the world, and that's a strange revelation to experienced technicians when they tour and they can't figure out what the sound is. But the key thing here, 125 volts and 15 amperes. Over here, we have one of our circuit boxes, and this is 6 circuits, and it's a little difficult to see on the actual plugs because they're black on black, but you see the yellow rotation sign because these are twist locks. However, not only are they twist locks, they are 20 amp twist locks. Now that means that the wiring behind this box is bigger. It's a thicker gauge of conductor in the wiring, and it will handle more current safely, and so is everything else in the arrangement. Some of the circuits in some of the buildings look similar to what the orange one looked like, but they're a bit different. This is actually a specialty plug that is capable of accepting the plugs that are intended for 15 amps, which have two vertical connectors, or a North American standard 20 amp plug, which has one vertical and one horizontal. So this is actually a 20 amp circuit behind this, the same way as the twist locks. And it's not a common plug to have this combination in it, but it's because certain pieces of equipment used in the room required a little more power to operate. Here's a close-up view of some of these things. These are the male plugs, and I can safely leave it up to you to figure out why these are male plugs as opposed to female plugs. This is the 15 amp plug, regular kind, and this is the twist lock. Okay? And the female ends, twist lock, and this one here. So sometimes these are called Edisons. Around here they tend to get called U-grounds because the long pin is shaped like a U. But while I'm on that topic, each of these has a longer pin than the other two. And that's because that pin is always connected to the ground. And you can review the previous lecture if that's a meaningless statement to you. But the reason for that, clearly, is that when you put them in, the male plug for the ground contacts the female first, and it disconnects last. So your ground connection is always safest. These short things are adapters, and they're used for converting from one to the other. You do have to keep your wits about you because, in truth, this connector here is rated for 20 amps, and although there's a huge safety factor in it, this one here is actually rated for 15 amps, and it's a little, haven't had the luck to find the rating on this cable, but it could easily be rated for 14 amps. Now, this one here is rated, it's a number 12 gauge, and that is the rated cable for 20 amps. If this is a number 14 and there's no label visible, then that's really only rated for 15 amps. However, this allows me to demonstrate the twist lock. You'll see that the ground on a twist lock has a bent pin. It has a turn in the pin. They're a little hard to see. One of these will have that same turn, and you have to match them up, push it in, and then a slight turn will lock it so that it can't come out. And in order to take it apart, you have to unlock it, and then it will pull apart. Hence, the name twist lock. We do have a fairly large inventory of cables, although sometimes you wonder if we have enough, depending on what we're doing and how many of the theaters are in operation at a given time. They are organized, and that's something we would like to make a very careful tradition out of. So, for one thing, they are color-coded for length, and you don't have to guess. You just look, there's a piece of blue tape, there's a piece of blue tape. Second of all, they are also, strangely enough, color-coded for what they are. So what that actually says on the orange at the bottom is U ground. I'm not particularly fond of combining colors with the orange, but so be it. I'm not the one making that call. But if it has an orange, it should be a U ground no matter what. So please keep track of that. Then we have various kinds of adapters. You've already seen the male U ground to female twist lock, and you've seen the reverse one, so which is male twist lock to female U ground. You haven't seen this kind of curious connector here. It's simply another kind of power connector. It's called a power con. It's used in a lot of the intelligent fixtures and so on, but it would typically be male twist lock or U ground, but more often than not twist lock to power con. And then we have here a set of what we refer to as twofers. If you remember correctly, I talked about a situation where you might have to understand how much capacity one of our circuits and dimmers has because you were dividing the connection. This is what that is. This is a twist lock twofer or Y connector. The last thing in this card at the moment is a curious beast. We call them SOCAs because the company that makes them is Socapex, but everybody just says we'll need a SOCA. And what a SOCA is a 6-circuit multi-connector, big, thick 6-circuit multi-connector. And our circuit boxes in the ceiling and various other places have the female connection for this. Here's the male. And you can see that it's got a lot of pins. In fact, it's got enough pins to have the ground connection and the the white and the black for 6 circuits. And then, so this thing in my hand is not the SOCA itself. They come in lengths up to 100 feet. This is what's called a tail. In this case, it is a tail that has 6 female twist locks. And they are increasing in length from 3, 4, 5, 6. This allows you to hook into one of the circuit boxes, run a SOCA of the appropriate length, and then at the other end have 6 cables to connect into, and it's like running 6 theater cords or 6 extension cords, but it does get you into needing to be pretty systematic. So each of these is labeled, but that doesn't necessarily make it easy to figure out what every one of them is. So as soon as you start running SOCAs like this, somebody's got to be putting temporary labels on them so you know 2 is not just 2, it is actually circuit 49 or whatever. So it's part of building your lighting plot. But we have male and female twist lock tails, male and female U-ground tails, and the same company makes tails for a number of different theatrical connectors. So the last thing in this episode today is going to be winding cables. Now, or coiling cables. You noticed that the cables hanging on the rolling rack were very neat. And if you've wound cables or hoses or whatever before, that you probably have made certain assumptions about it. Now, in our theater, if you don't know what you're doing, those assumptions will get you into trouble because we wind our cables in a specific way. And if you don't know that and you take them apart, you are going to end up with a chain of little knots like this. Let me explain why after I take these apart. In order to get a cable or a connection of connecting hose or something like that to lie nicely in a coil, you are having to put a turn every time you wrap. Every time you wrap it into a circle, you are putting a turn, a twist in the cable. Okay? So what I mean about that is if you coil anything, a hose or whatever, you know you can't just do this. You have to make it turn by rotating it in your hand so that it wants to go into that circle. What I'm actually doing is I'm grabbing this cable and I am twisting it to let it make that loop. Okay? Now, this is the way that most people would automatically do that, and they would put each turn on the side facing the camera. So that's called over. Okay? If you've done this much, you would realize that when you wind up an extension cord like that, you're continually having to do this kind of a motion to unwind it, because you're putting a turn in it over and over and over again. So that's okay, except it's not okay in things like microphone cables and data cables that are not as heavily built as these cables are. And so for years, sound technicians have been doing something different. And so, ironically enough, is it common practice? It's common practice to wind up a compressor hose in a different way. We've standardized here. And what we've standardized that explains explains why, if you don't know what you're doing, or you don't know that we've done what we've done, you're going to end up with a ring of little, or a long line of little knots. It's become the rule here that all cables are wound the way mic cables and data cables have been wound for some time, and that's called over-under. The first turn is the same as before. But the next turn, instead of my hand going this way, I'm going the opposite way. And I'm turning the cable underneath. So over, under, over, under. And that is twisting, untwisting, twisting, and untwisting. That's effective for a number of reasons. One is it eliminates having to do that flipping motion to get the twist out of the cable, but also because it avoids building in a permanent twist into the cables, especially the lighter cables that have quite thin wires wrapped in often a woven copper sheathing, and that can get a permanent twist built into them, which makes them a little hard to use. However, if you inadvertently pull the last end through the middle of this, you're going to get a knot for every coil all the way through. So you do have to make sure when you take it apart that you pull it out sideways. So you can get anything, a rope, a long extension cord, a hose. This is something you can actually do at home. You can practice this. It's called over-under. And I'm sure if my explanation didn't make any sense, I'll bet you dimes to donuts that there are YouTube videos of people doing this.